In this video, we're going to demonstrate how Snort Engines can be fooled by mutating the exploit. In this case, we're going to use a famous exploit CVE 2012-0507, and that was the famous one that get toolkits like Black Hole created. That really was very effective both in Macs and PC. This is a Java vulnerability that was cross-platform, and also there were variations like the Redkit and Phoenix exploit. It was a very famous one. And what we have is actually three virtual machines that we're going to use for this demonstration. One is where we have our XGS appliance, virtual appliance in this case, that has both the PAM engine as well as the Snort engine. And if you didn't know, we have the capability of running them both, and they are both enabled here, and I'm going to be alerting. They're not blocking, they're just alerting about attacks. Then we have a second virtual machine that has the Kali machine here, that basically has a meta-exploit framework that we are going to use because it has an exploit for that particular CVE. We also have this XP that by clicking on a URL that points to this server where the trap is set for him to go, when the user opens or clicks on anything that takes him into that site, we exploit that vulnerability and we basically take over the machine. So let's start showing that live. So this is the IPS the virtual machine. This is the Windows one, and this is in the Kali. So here we show, the date and time for you to see that the actual exploit occurs at the other end. We show the IP config to see that this is the IP address of that particular box. And in here, we're going to go to the console of our IPS, and we are going to be actually clicking here on the system alert, and we see that we don't have right now any alert because we haven't started with the attack. So now we open the Kali Linux, and we're going to go to the meta-exploit framework, and we launch it, and here it is. So we're going to search for the exploit for the vulnerability that we mentioned before, and here it is. So we're going to be using that exploit. So I'm going to be copying this long name here to use the exploit. I'm going to actually use that exploit. I'm going to paste it now, and bingo, I'm ready to use it. Now I need to set a couple of parameters: server host, the URI path, which is JavaBug, the payload, and the local host. And we just click exploit, and the trap is set, just waiting for for a fish to take the bait. So we open the browser and we go to that URI, that is that server, and we see that immediately we compromise that particular machine. So for further proofing that we took over that machine, we can look at the session, and it really tells us that this is the Windows XP system, and we are at the desktop of that machine. We're going to go actually to the root. Let's do a directory here to see what files do we have on that machine. These are the ones. Let's do the same thing on the actual machine. So we go to the other virtual machine, we close the browser. Now that machine is taken. So we go in here, we see that the dates and all that matches. So we go to the C directory, and we see that we have actually completely taken that machine. Now we got we see that this is the same set of systems. So we go now to the console of the XGS, and we click on security alert, and we see that we have a bunch of alerts coming in here. The ones at the bottom are the PAM engine, and the ones at the top are the Snort. And we actually, when we open them up, we see that these are all Snort signatures that fire on that attack, which is was expected. Snort published some signatures to catch that type of actual attack. These are the PAM ones. As you see, the name Snort is not anywhere in there, and these are the one that is the protocol analysis module that is not based on signatures, but actually on the way that the actual protocol is actually used, or in this case, abused. What we do with that exploit is that we're going to copy it, and we're going to be renaming some of the classes. Like instead of exploit, we're going to call it something else. We're going to be copying the files that are in a subdirectory X. We're going to copy it in a subdirectory Y. We're going to introduce some comments. I'm going to go through each and every one of the steps. I'm going to go in kind of a fast forward to make the video short, but every one of the steps are being put in here for you to check it if you want to. So we created a temporary directory. Then what we do is that we copy that exploit into the current directory. We expand the jar file, we extract the jar file, we create a temporary directory Y instead of the one that is the previous one that uses, which is X, and we move into that directory. Then we copy that all the files that are on the X into the Y directory where we are. The next thing that we do is that we decompile those three classes, exploit, help, and payload X. We actually, after we do that, we are actually gonna rename the exploit.java into something else.java. We do the same thing with the other two classes, the help and the payload. Here we are in the editor, and we replace the exploit by something else. We change the directory, and we do it here also on the public name of the class. We need to change that directory that points to X into Y, which is where we copy all our stuff, right there. Y, and we are going to copy this buffer because we're going to use it in another file that another program that we're going to use to completely recreate the file. So we save it. We are done with that. Now we create this file that is called Java convert, Java_convert, and we basically copy it and put this buffer and some more code in it. And let me show you just the rest of the code for your reference in case that you actually want to use this. And this is going to be outputting the output.bin. So we run the program, and it runs, and it generates the output.bin, but we need to change that reference to X here into Y. So we do that, we save that file, and we're done with that step. Next, and I'm going to go quickly in here, we edit the something else of Java, and we're going to change the buffer and change again that 120 is X, 121 is the ASCII for Y, and we change that. We save it. We're done with that step. A lot of steps, but hackers do this very, very easy. Now we go into the other class, the help.java. We change the directory, and we change the name of exploit to something else. We change those directories. Instead of X, we change them to Y. I mean, a lot of steps, but again, hackers do this very, very easily. We are transforming the actual code, and you'll see how this fools the Snort engine because the signature of it has actually changed. The thing that Snort is looking for are not going to no longer be seen, and hackers can easily do that when they know that they are a Snort engine. So let's do the same thing with the payload X class, which is the last one. Again, we change that directory. That's all we need to do here. We save it. We're done. Now we go into that temporary file, and we create a make file, and I just paste it in here. I had it something else, someplace else, and I'm going to run create a temporary directory and run the makefile for doing the compilation. So we run the makefile, run successfully. We add almost done. Now we're going to do the Ruby, the change on the Ruby file, and instead of call that CVE, we're going to call it myjar, which is the code that we are actually going to be using for the exploit. So, and we're going to insert here 2 comments. We're going to replace that directory, replace the exploit by something else, and we're going to insert 2 comments just to fool again different parts of the Snort signature that are looking for these fixed names. We're going to change those. So let's go down here and insert some comments. Again, this doesn't change the logic of the exploit, it just changes the signatures and therefore full Snort Engines. And we're going to do the same one. Let's do it on the next line as well. To make a couple of changes, let me actually paste it. It's pasted in there, so we have that. We save it, and we are basically done here. Copy the myjar file into the directory used by the exploit, and we need to change the mode for allowing it to execute it. We're done. We go back to the Metaxploit framework. We send the same variables as before. Nothing changed. My trap is set. I go to the other machine, click on the URL, and as expected, the machine is taken as before. But what is it that has changed right now? We go into the same console, we clear the previous alerts, and we go now and we see that the Snort signatures are not there. Snort is not detecting this attack, but the PAM module, because it looks at the way that you abuse a protocol, actually catch the very same alerts that fire before, fire now. You see, it cannot be full. The Tolly group run a test similar to what we did in here with several exploits. So it started with some exploits, and our IPS catch 99% of that, and the Snort catch 91. Not bad. But what happened when those exploits were mutated exactly in the same way as we did before? So we took 30, well, they took 31 of those exploit and mutated one, and as you saw in this video, our IPS were able to catch them, each and every one of them, while Snort catch only half of those.